Right, hey guys and girls, ladies and gentlemen, welcome back to BBR Suspension. So we're pretty much on the home stretch now on the Porsche suspension. I've got the cross strut welded in on the lower control arms, and what we're going to be doing today, I've turned up a dummy rod end. Okay, so this rod end is the actual bottom of the shock absorber, and the two sleeves which are on either side need to go through the actual lower control arm, because the shock absorber mounts in the actual control arm and goes up to the chassis at an angle, so that as the control arm moves up and down, the shock compresses and uncompresses. So basically what I've done, I've turned up the dummy rod end, and I've got the two sleeves which are going to go through the actual lower control arm. So what we're going to be doing today, we're going to be making, or let's say punching, some holes through these lower control arms that these are going to mount through. And then what we'll also be doing is there's going to be another sleeve which goes through the control arm from the top downwards, okay, and that is where your anti-roll bar mounts through. So the first ones that we're going to be putting through the sides, we're basically going to have to rig up a little bit of a creative system, let's call it. So what I've done, I've got the mill set up. So I'll be using a 90-degree angle head, and because we're going to be drilling into the side of the control arm, which is at quite a steep angle, I'm going to use a 2-flute slot drill to first pierce a hole through. And once we've got the hole pierced through, we're going to be using a 16mm hole saw to cut the hole through the tubing. Obviously the locating drill will be running off on the tubing, and that's the reason why we're using a slot drill to basically do a guide hole, so that the drill can pick up on that hole and guide through. So conventionally on the mill you'd basically be drilling downwards with the slot drill. In the angle head we are going to be drilling across, so we're going to move the entire table with the workpiece on. And what I've done, I've got the jig that we used for welding it, I've got it clamped up on the table, and what we'll do one side, we then flip the control arm over, we'll do the other side, we'll then bring the second control arm on and basically do the same to get those 4 holes pierced. And then once we've got that done, we'll take the angle head off, we'll set up the mill, or bring it back to conventional vertical configuration rather than horizontal. And what we'll do, we're going to have to angle the head, because the hole that goes through for the anti-roll bar has to go in at a 5-degree angle. So we'll do the setup probably off camera, just to give you an idea. To get this set up all clocked up and set up correctly took me about 3 hours. So we'll do the setup off camera, we'll do the holes at a 5-degree angle through the top of the arm. There's one on either side arm, and once that's done, what we'll be doing is the little sleeves, instead of TIG welding them through the tubing, we're actually going to braze them in. So the reason why we're going to do that is twofold. The brazing will give us a slightly better fillet radius, which is slightly stronger, and then the second reason is because we're going through the tubing, we don't want to build up any thermal stresses in the tubing at that point. So by brazing it, we use a lower temperature, we don't melt the parent metal, we'll be using bronze brazing rods. So by not melting the parent metal, we don't create high thermal stress points in the material. And then what will also happen is it'll slightly heat the end where we have welded, and it should relieve any stresses that are in the side of the material. So that's what we'll be doing today. So what we'll do is we'll get started with punching a hole with the slot drill, and then getting over to the hole saw and getting the holes made. Right, let's get cracking. so what we'll do, I'm going to give it a quick changeover. We'll pop the hole saw in. Just get our clearance. Right, nip up that right now. Should be able to pick up that center hole pretty well. Got the first hole through. So we'll just get that taken off. Long nose pliers on the table there, please. Right, let's get that out the way. Then we might have to use a slightly longer slot drill to put a guide hole through on the opposite side. Being at an angle, I'm a bit worried that the center drill will run off, so I'm rather going to do that to make sure we pick up that center drill. So I'll switch over again. Just got to extend this out a smidge, coming up a fraction short there. Right, so that's one side done. We've successfully punched a hole through. So what I'm going to do, I'm going to flip this over. I'll do that off camera and we'll get set up and we'll do the other side, and then we'll change over to the second arm and get the second arm done. But so far I'm quite happy with how things are going, so looking good. Right guys, so I've got the jig changed over to do the hole for the anti-sway bar or the anti-roll bar. So basically what we've got to do, we've got to do this specific arm on this side leg and the opposite one on the opposite leg. So I'll do one and I'll have to turn the jig and then we can do the other one. It's a 5-degree angle, so I've tilted the head of the mill 5 degrees outwards. And what we're going to do, I've got the tube lined up perpendicular to the bed. So we're going to get the center of the tube. We'll then spot basically on the line that I've drawn across the tubing. Got the distance measured from the end. We'll spot it and then we'll pierce it with a hole saw and go through. So let's get cracking. So we'll lock the x-axis at the halfway mark. We'll put a centre bit in. I'm hoping that the centre bit being nice and short will be okay with the 5-degree tilt. And then we're just going to get the Y onto that mark. Let's give it a bash. Yeah, that's working fine. I'll just grab some cutting oil. Quickly see if we can hook that off. Fell inside the tube, not the end of the world, we'll get it out. Right, and we're through on this tube. So what I'll do next is I will turn the jig, get the other arm in, and the other arm we do the opposite side tube, because on these arms we will have a left and a right. So I'll get that done quickly off camera, and then we can drill that hole, and then we should be good to clean them up and get cracking with the brazing of those tubes. Right guys, so we've got the jig changed to the other side. I'm going to bring this over so we can find the center of this side tube. We'll get this down. Zero X. Get the center point. swap over to our center bit, and we can get onto that line. Let's swap over to the hole saw. Just drop that speed. Try and get that piece to not fall inside the tubing. There we go, we have all the holes poked through the lower control arms. So we'll get everything cleaned up off camera, and then we should be ready to braze the tubes in. And we're pretty much done with this job, apart from the pivot bushes, which are nylon or type of nylon. So those are pretty quick to turn up on the lathe. So far so good. So I'll get this cleaned up off camera and we'll see you back at the brazing bench. Right guys and girls, we've got all the holes pierced or punched through the lower control arms. So what I'm going to do now, I've deburred the holes and I've cleaned all the swarf out. I'm going to give everything a wipe down with some acetone, and just to make sure. I have used a little bit of degreaser to get the cutting oil off, but when you're brazing you want the steel to be pretty clean, so that the flux can adhere. So what I'm going to do, I'm going to give everything a wipe down with some acetone and just get it prepped for brazing. Just take a little rag, get some acetone on, and I'm going to wipe down the little sleeves that are going to go through. Give those a little wipe. Just pop them one side once they're done. So the acetone basically will remove any residual oil that's on the metal, and it evaporates pretty quickly, doesn't leave any residue, so I think we should be good to go there. So we've got those wiped down. Smidge more acetone. I'm going to wipe the control arms, basically everywhere we will be brazing. Give those a wipe down. Like I explained earlier, I think the brazing will give us a slightly bigger fillet radius, and it's not going to create any thermal stresses in the material, so I think at the end it'll give a slightly stronger joint. Different strokes for different folks, but on material like this I think you want the strength component. It also does give a nice finish. In the days gone by, many motorcycle frames were brazed rather than welded, and never heard of any of those falling apart, so I think the brazing will be good. So what I'll do, let me get the acetone away from the bench, and then we'll mix up some brazing flux. So what I do, I mix up, this is a powdered flux, I mix it in a little aerosol cap with a little bit of water to make a paste, so I can brush it on and I can control the area where we put the flux down. The flux will also help to clean up the material. The one thing with the brazing is where the sleeves go through, you get the actual braze material will pull into that joint through capillary action. Okay, so it'll actually fill that, and that's what gives it the strength that we want. Where you're welding and you're melting the parent metal, you're not going to get any specific material going into that joint, and because we've limited the amount of material left, I'm going with the brazing route. Like I said, I think it's going to give us a stronger joint. Right, so we add a little bit of the powder to the water, and I can just use the back of a paintbrush just to mix it up. We want it a little less runny than that, so I'll add a little bit more. Get a paste consistency. Basically, when we put it on the metal, we don't want it to run, so that's the reason why we want a slightly more paste consistency than a liquid. So your bronze brazing flux is predominantly borax powder. I think there's a couple of other things that they put in, but as far as I'm aware, it's predominantly borax. So you can see that's a nice pasty consistency. We should be able to brush it on and not have it running all over the show. I think we should be good to get prepped now. I'll wipe the back of the paintbrush off, the rag, and we can get the flux out the way. Right, so I've turned up the dummy shock eye or rod end for the shock, which is basically going to go in the center. We're then going to insert a sleeve from either side. Okay, and then I've turned up two little spacers which are going to sit, because the standard M12 nuts is a little bit too close to the tubing. We'll probably make up some special cap screws with a male-female thread which joins internally in the sleeves to mount the shock, so that we keep the spacing as tight as possible. And the idea is that this is just finger tight, just to hold everything together so that we can tack it in. So what we'll do, we'll put a bit of flux on these joints, and then we'll get a tack around. So the flux paste we can basically paint around where we're going to be brazing. We want to get that flux onto the material. So as we apply heat, the flux will melt. Okay, and as it melts, it will clean the parent metal, and it also prevents any oxidization oxidizing of the parent metal. So that is the reason why we use flux. We don't want the parent metal oxidizing, we want it nice and clean so that the actual bronze can adhere to it. Right, so that should be good. We've pretty much gone right round with the flux. What we'll do, we'll get a tack on 2 or 3 spots, and then we can remove everything else out the way and we can do the actual braze. Let's just make sure on the other side, I'll just double check. We have got everything fluxed. Yeah, it's looking pretty good. Right, I think we're good to go. What we'll do, we'll get 2 tacks on and then we'll loosen everything and then we can do the actual brazing around. So I'll change from my Mickey Mouse to get my brazing goggles on, and then we can get cracking. Right guys, so we're gonna run a fairly gentle flame. I'm using a number 5 nozzle. We want a slightly more carburizing flame, so less oxygen, more acetylene, so that we don't oxidize the metal. So that flame looks good, and we're using bronze brazing rods. So what I'll do is I'll heat everything up a little bit. You can see the flux paste is now, the water is evaporating out, it's drying out. And we'll get this heated up and get a tack on here. Right, so we've got the bronze flowing there. We'll get a little tack in that sleeve. We can do the same on this side. With a threaded rod inside the sleeves is absorbing a little bit of heat. You can see it taking a little bit longer for the bronze to run onto those sleeves. So we've got a tack on both of those. This side one needs a smidge more heat onto that sleeve. You can see the bronze hasn't quite stuck. You just try and get it flux. Right, there we go. That has got a nice tack onto the sleeve. What we'll do, we'll kill the flame quickly. These things are going to be pretty hot, so what I'll do is use some welding gloves and see if we can just get the nuts loose and get the fittings out. That way we should get, yeah, it's hot. We'll get that out the way. Get the little spacer off. And we should be able to tap this. That's the dummy shock eye. Right, so now we won't be absorbing all that heat. And what we'll do, we'll get this raised up. So nice gentle flame. We give it a smidge more oxygen. So we'll start on the outside here.